This video is to help you prepare for the Unit 5 test. We're going to be going over Quiz 1 and how you should approach each of these questions. Now notice it is calculator permitted. So we want to use our calculator to the best of our abilities. Okay, so if C is a number that satisfies the conclusion of the mean value theorem for f of x equals x cubed minus 2x squared on the interval from 0 to 2, then C equals, we don't know. So mean value theorem says that there's a value C somewhere between A and B, so that the instantaneous slope at C is the same as if we took the 2 points and found their slope. So it's the same as the secant slope between those 2 points. So the graph may be doing something kind of crazy, and here's the slope between those 2 points. There's got to be another point where the tangent slope is the same as that one. So, in other words, we're going to have f prime of some value C is going to be the same as the slope between those 2 points. So f of 2 minus f of 0 over 2 minus 0. Well, let's figure what that is first. So f of 2, we plug 2 into there. So 2 cubed minus 2 times 2 squared is actually 0. 0 minus 0 over 2. Okay, so that helps. So now we're trying to figure out when the derivative equals 0. Well, let's see. The derivative, f prime of x, equals 3x squared minus 4x. Alright, so see they both have an x. I'm going to factor that out. X times 3x minus 4. So there's 2 places where the derivative equals 0. At 0, but that's one of the endpoints, and we're not going to consider that. And the other place is when 3x minus 4 is 0, which would be 4/3. If the graph of y equals x cubed plus ax squared plus bx minus 4 has a point of inflection, point of inflection is where we change concavity. That means my second derivative is 0. So the point of inflection is at 1, negative 6. So the second derivative is 0. Gosh, there is a lot of stuff missing there, but we can take the second derivative, right? The first derivative, y prime, would be 3x squared plus 2ax plus b. Second derivative would be 6x plus 2a. Ooh, this is... They want to know what b is. Well, let's see if this helps. 6x plus 2a. So that's the second derivative. The point of inflection happens when we're at 0. And I know that when x is 1, I'm supposed to get a 0 there. So I should erase that. 1 is supposed to give me a 0 because it is supposed to be a point of inflection. So 6 times 1 plus 2a should give me 0. Well, that's 6 plus 2a. So 2a equals negative 6. A is negative 3. Oh, I'm supposed to be finding b. Oh, I know this is a point on the line, right? That's an x and a y on the original graph. Well, let's plug in everything we know. We know the y value. We now know a. We don't know b yet. That's what we're trying to find. Oh, I forgot. We knew an x, the x that gives us that. I forgot to plug that in. Wow. 1 squared, that's okay, plus b minus 4. That's 1. So I've got 1 minus 3 is a negative 2 minus 4 is a negative 6 plus b. So b is 0. Three. Let f of x equals the square root of x. If the rate of change of f, derivative, at x equals c is twice the rate of change at 1. Ooh. Alright, so first, rate of change, we're talking about the derivative. So that's really f of x equals x to the 1/2. So when I take the derivative, I get 1/2 x to the negative 1/2. Or 1 over 2 squared of x. That's easy to work with here. So, the rate of change at x equals c, we just plug in a c, is twice the rate of change if you plug in 1. Okay, well that gives me a 1, and 2 divided by 2, that's a 1. So I've got 1 over 2 square root of c equals 1. In other words, 1 equals 2 square root of c. So square root of c equals 1/2. So square both sides. C equals 1/4. Number 4. Let y be a function that is differentiable. Good, that means it's continuous and differentiable. It's going to meet everything. On the open interval 1 to 10. F of 2 is negative 5. Okay, so, and f of 5 is 5. And f of 9 is negative 5. So I'm going to think about that for a second. Thinking about a line. F of 2 is negative 5, f of 5 is 5, and then f of 9 is negative 5. The function has to have at least 2 zeros. Yeah, the graph's going to have to go, if it's continuous and differentiable, it's going to have to go up and then back down. So I agree, 2 zeros. Graph of f has at least 1 horizontal tangent. Well, yeah, if it turns around somewhere between here and here, which we know because it has the same endpoints, that's, I believe that's Rolle theorem, it has at least 1 horizontal tangent. It also says that between 2 and 5, here was 2, and here was 5, there has to be some number that gives me a y value of 3. Well, if I'm going from negative 5 to 5, I have to pass through 3. So that's true too. Knowing that it's differentiable and continuous, all of those things are true. What is the maximum value of the function x squared sine x on the interval 1 to pi? Now, so this is multiple choice and calculator allowed. I'm going to be honest. Why don't we just go in and find the maximum? Now, it said only the interval from 1 to pi, so I need to change my window a little bit. Y equals window 1 to pi. Now I'm looking for the maximum value. I can see that it went up. I can't see that maximum though, so I'm going to change my window. Let's try 5. Especially because none of these numbers are bigger than 5. Oh, I see the maximum. So I have my f of x and my y equals, and I want to find the maximum. We can actually go to calculate maximum. Left bound, right bound, go to the right of it, press enter, enter. The maximum occurs when the x is 2.289, but the maximum value of the function is actually the y that goes with it. That is the maximum value. And that's the common mistake on that problem, is that people will mark the x because it's there. But when we talk about the value of the function, that means your outputs, which is your y. For t is greater than 0 hours, h is differentiable. Good. Like to hear that. That means it's continuous. And it's nice and pretty. That gives the temperature in degrees Celsius at an Arctic weather station. Which of the following is the best interpretation of h prime of 24? Okay, so the derivative at 24, t is in hours, so that's 24 hours. Now, is it the change in temperature over the first day? No, because that would be between 0 and 24, so that would be an average rate of change. Change in temperature during the 24th hour. Well, that'd be between 24 and 25. The average rate at which the temperature changed during the 24th hour, the rate at which the temperature is changing during the first day, and the rate at which the temperature is changing at the end of the 24th hour. Okay, so it's the rate at which the temperature is changing at that moment, at the 24th hour, not during a time period. Remember, it's instantaneous rate of change. Okay, number 7, last multiple choice. Let f be a function that is continuous. Continuous. Check. And it's talking about IVT, so that works. Okay, on the closed interval 2 to 4, f of 2 is 10, f of 4 is 20. Which is guaranteed by IVT. That means if I'm going from 10 to 20 for my y values, I have to pass through everything between 10 and 20. So, number 1, f of x equals 13 has at least one solution. Yeah, 13 is between 10 and 20, so that's, yes, it guarantees that. Does it guarantee that 15 is exactly where when x is 3? Can't guarantee that. F attains a maximum. I don't know that. All I know is I went from 10 to 20. The derivative equals 5 has at least one solution in the open interval. Now the problem here is that kind of makes sense, because if I looked at this, 20 minus 10 is 10, and that's over 2 points. So I know that my secant has a slope of 5. And I want to talk about the mean value theorem and go, well, that means I'm going to have a derivative of 5 somewhere in there. But remember, for mean value theorem, you have to know you are differentiable as well. I don't know that. Derivative is greater than 0. Do we know it's increasing the whole time? Or could it have started out at 10 and gone down and then back up to 20? I don't know what it did. The only thing that is guaranteed is IDT. Free response. The function f of t below represents the temperature outside of a house during a 24-hour period of time. So we have the function, and that's pi t. It's kind of hard to see it. Okay. What is the value of f prime of 10? Now, this is a calculator portion, so, but I'm going to go ahead and make sure I show that you should be using your sheet for the free response. So f prime of 10. So I'd start, I still want to show what I know. You get points for everything. So 80 minus 10 cosine of pi t over 12. Now make sure I remember this is between 0 and 24. So, whoops, that was f of x. Sorry, f of t. The derivative of 80 is 0. So I'd have the derivative of cosine is negative sine. Well, we already had a negative 10 in front. So if it's negative, and it's already negative, that's going to be positive 10 sine of pi t over 12 times the derivative of the inside. Well, the derivative of the inside is just pi over 12. Now I can plug in f prime of 10. Is, you can go straight into your calculator and type that in. I got 1.309. Then it says to interpret this value in the context. So, 10, that was time. So, at 10 a.m., the temperature, positive. The temperature is increasing because my derivative is positive at a rate of 1.309 degrees Fahrenheit per hour. Part B says, is there guaranteed to exist a value C on that interval? And this is a cosine. We know it's going to be a nice, it's a wavy curve, but it is differentiable. So, such that the derivative equals 0, justify your answer. And find it if it does. Okay, so, I need to say that f of t is continuous and differentiable. On that interval. I know there are no sharp turns, no holes, no nothing, no asymptotes. I know it's continuous and differentiable. Now, since I'm looking for when we have a derivative that is 0, that'd be a possible max or min, I'm going to think about Rolle's theorem. Rolle's theorem is the one where if you have your endpoints are at the same spot, then you had to have turned around somewhere. So I'm going to plug in 0, and I'm going to plug in 24. So that part, it doesn't need to show in the problem. And remember, we're plugging into the original. So 80 minus 10 cosine of pi times 0 divided by 12, about 70. And if I go back in and I change that to 24 divided by 12, I also get 70. Oh, Rolle's theorem. So f of t is continuous and differentiable, and f of 0 equals f of 24. Therefore, Rolle's theorem guarantees a value C on that interval such that the derivative at that point is 0. So, the next part of B was actually find that. So, I'd already taken the derivative. And I'm just going to clean it up a little bit. I'm going to take the 10 and multiply it with that just to make it prettier. So 10 pi over 12 sine of pi t over 12 equals 0. And I'm solving that equation for t. Do they care how I solve it? Not at all. So I'm going to type in that function into my calculator. Oops, forgot the x. Now, I need my window to go between 0 and 24. And I know that temperature is going to go from 0 to at least 70, right? So I'm going to go 75. But I'm really trying to find when it's 0, so I'm going to change that back to -5. I don't really care how high it goes. I forgot. I'm trying to find when it's 0. Right there. Zero. To the left. To the right. X equals 12. So, in our case, C, we're trying to find the value C, is 12. Free response part C. Is the temperature increasing or decreasing at 9 p.m.? Well, increasing or decreasing has to do with slope. It has to do with our first derivative. So I need to plug in 9 p.m. Wait, that's not 9. If I plug in 9, that's 9 a.m. 9 p.m. is going to be at t equals 21. Okay, so f prime at 21 is approximately, because I'm going to be rounding, negative 1.851. So it's negative. So I would say, since f prime of 21 is less than 0, the temperature is decreasing at 9 p.m.